Greetings from India, and the title has already been announced. All the three of us will make the presentation. Next slide, please. As you know, Telugu is a literary Dravidian language spoken in southern parts of India, and it belongs to the Dravidian family. The script is associated with Telugu. It is a Brahmi derived Abugida. Like all Abugidas, Telugu makes use of orthographic syllable called Akshara as a basic unit of writing, and the direction is left to right. All basic Aksharas of native Telugu have open syllables, CV syllables. Only coda position, only nasal is allowed. But borrowed words, we use extensively borrowed words from English, Hindi, Sanskrit. They can have closed syllables and also clusters right in the onset. So basically, even though next slide I'm going to show you some of the basic aksharas, both vowels and consonants, but the actual aksharas we use in writing are much more than these because of the borrowed words. Next slide, please. So on your left, you see the vowels, the primary letters. On the right are the consonants. Again, as I mentioned to you, all the consonants come with the inherent vowel A. Next, please. And there are 35 consonants and 16 vowels we have worked with. Yeah. Next, all the vowels are modified with this diacritics, if you can call it, or graphons, according to some terminology. So if you take ka and then you add this first one, it becomes long ka, then ki, ku, like that, vowel modifiers. Then on the right side, you have consonant modifiers like ligatures for geminates, as explained in na plus na, or clusters, ta plus la plus u, clu, the first one. Next, please. The orthographic syllables in Telugu have a visuospatial logic, so if you see the C in the middle is the inherent consonant, all the vowel modifiers appear on top in X position. Okay, this is exclusively fixed for vowel modifiers, and they're always attached to the C. Whereas in position Y, you get only secondary symbols for consonants, and they're never attached to C. And position Z accommodates both some of the vowel modifiers and some of the consonant modifiers. Next, please. So if you take a conjunct consonant like sp, the left one is called sp, like in a word like spirit, or the right one is called spu, like spurti, which means inspiration. So here the vowel is attached to the first consonant and not the second consonant, even though in speech the second consonant should carry the vowel, the modified vowel, which is indicated in red. Also, the O comes at Z position. Therefore, visuospatially, it takes up longer space. This non-linearity, which applies to some of the conjunct consonants, we feel might affect the number of orthographic neighbors, as well as the difficulty in learning and reading and spelling Telugu. Next, please. So to examine this intuitive feeling that I've had over the years, we took up the present study with the following. So basically, we take off from Chang et al. 2018, who talked about multidimensional measure of visual complexity called GraphCom, which they applied for 131 languages, including Telugu. Next. So we used the 4 dimensions of GraphCom and calculated again because we could not have access to the codes that they used. We talked to them, but we could not get. So we recalculated. Next. But then we went on to calculate grapheme complexity for orthographic syllables which appear in 200 meaningful words. And we designed an algorithm to calculate orthographic neighbors for select Telugu words. So in this presentation, because of time limitations, we will present results in relation to grapheme complexity of meaningful the two-syllable words, and how that is related to number of orthographic, neighborhood, a number of neighbors, orthographic neighbors. Next, please. So the data, the Central Institute of Indian Languages, Mysore, developed a 3 million word Telugu text corpus, which is called CIL corpus. From that corpus, they have listed 1,000 most frequently occurring printed words. From these 1,000 words, we have selected 200 two-syllable words, and that is the main database of our study. Now, next, please. So now with the technical part, Sohan will present the technical part of how we calculate it. Sohan, please take over.
Hello. Am I audible?
Yes.
Yeah. Start.
Yes.
Start.
So let us now see how each of the four GC measures, graphic complexity measures, are calculated. The four measures are connected points, simple features, disconnected components, and parametric complexity. So we will see for an example of letter H in English. So we see how we draw the character H. So we have three strokes, two vertical and one horizontal. So these three strokes constitute the simple features. Simple features are defined as a number of loops, lines, or simple curves or dots. So these only constitute the simple features. So connecting the simple features will have the intersections. So in H, we can see the corners where the right angles are, those are the connected points. And if we draw a character with a connected pen like this, so the whole H part is a single stroke. We can draw it in a single stroke. So it will become a disconnected component on its own. But letters like I are disconnected, so they have two parts. So this way, the number of disconnected components is calculated, and perimetric complexity is mathematically defined as the ratio of squared perimeter of the contour of the letter to the number of background pixels in the graph. So this is calculated mathematically.
Next.
This roughly corresponds to the ink density on the paper. And similarly, we see the complexity calculated for Telugu Akshara. This is Gha. So here we can see it clearly has three distinct disconnected components. And simple features, if we see, we have 5, which are a small circle and then 2 J-like curves and 1 tick mark and the bottom part. And perimetric complexity is similarly calculated. So next slide, please. So now we move on to the definition of orthographic neighbors in Telugu. So given a target word, we define its neighbors as those that differ from it in one akshara. And we change that one akshara through substitution, deletion, or addition. We do not change its position. So by substitution, we see this the first akshara is changed to a different akshara. So both these words should be meaningful. This is a constraint on this. So this is a neighbor, and by deletion, yeah. So deletion of that circle thing will get a different word, meaningful word. And by addition, also we can get other meaningful words. So this way we define neighborhood of a word. Next slide. We saw that as we did not have access to Chang et al.'s GC measures nor the code, we had to re-implement the algorithm for calculating them. So we had some differences in the values, mostly for PC, because it is connected directly to the font we used for the studies. So Chang et al. Used NATS font, and we used Noto Sans Telugu regular font, which is more common. And now we move on to the how GC value changes as we modify the basic shapes of aksharas. So the first akshara you can see is a basic shape ka, and we add a vowel modifier o to it to form ko. And in the third column you can see a geminate modifier is added. So the another consonant, the same consonant is added. So ka plus ka will become ka, like in akka. And the last one is la is added to ka to get kla. So we can see here the values for DC, CP, and SF are linearly added. And for PC, it gets increased because of the added modifiers. And now here we define grapheme complexity. So using modified aksharas, we get graphemes. So the graph of O plus graph of Ka joining together will get the word Okka. So Chang et al. Only defined the graphic complexity measures for syllables. So we extended the definition to whole words. So two syllabic words in our case. And we see that the values for DC, CP, and SF are linearly added. And for PC, almost linearly added. So there is a slight approximation there.
Next.
Yeah, now that we have looked at the definitions of GC, the complexity measure for orthographic syllables and two-syllable words, and also the definition of for orthographic neighbors, our research question was, how are these two related? So in the next slide, I'm showing the relationship between grapheme complexity and orthographic neighbors. And remember, orthographic neighbors are those two-syllable words that are meaningful, that are generated by substitution, addition, or deletion, right? So what we observe is that for simple syllable structure, ATA, which is play in English, it has 154 orthographic neighbors, whereas when the syllable structure is moderately different, this is a moderate syllable structure. This is the target word, wokka, that you have seen in the previous slide. For this, the number of neighbors is 93. But for a complex syllable structure like purvam is past or something in the past time, right? So that this word, a two-syllable word, has only 31 orthographic neighbors. So clearly the syllable structure and the number of orthographic neighbors that result in doing these deletions, additions, substitutions changes. And so the relationship is also measured graphically. What we are seeing here is one of the complexity measures, which is perimetric complexity versus orthographic neighbors, number of orthographic neighbors. As the perimetric complexity increases, the number of orthographic neighbors decreases. And this negative relationship is seen not only with PC, but other complexity measures like disconnected components, simple features, and the connected points. Yeah, number of ONs decreases. So the conclusion is ONs decreases as the complexity increases. So in other words, the number of admissible neighbors reduces as the complexity of the orthographic syllable increases. So to conclude, what we have presented today is two questions. first research question was what is the grapheme complexity of two-syllable words in Telugu containing different types of syllable structures? What we have seen is that the complexity increases for words containing complex syllable structures. We showed the example of basic shape and how orthographic syllable, the complexity increases, and for two-syllable words, it further increases. And it is not in for most of the measures, it increases linearly, but not necessarily, right? For perimetric complexity, we saw that two syllables added doesn't become double the complexity. The other question we addressed is the relationship between GC and ON. And we saw an inverse relationship between these two. As complexity increases, the number of neighbors decreases. So to summarize, we re-implemented the GraphCom measures that Chang et al. Proposed, and our results seem to be in line with what they have estimated. We extended those definitions to orthographic syllables as well as to two-syllable, meaningful two-syllable words, and looked at the relationship between these complexity measures and the number of neighbors. Among the GC measures, we see that PC and DC have relatively higher negative correlation compared to the other GC measures such as simple features and connected points. So these results make possible further research into how reading and spelling works in Abugida type of writing systems. Thank you for your attention. Yeah, I think we have 1 or 2 minutes for questions.
Yeah.
Questions? Yes. Can you hear me? Yeah, I just wondered if the effect, this very nice effect of negative correlation, was due more to neighbors from substitution, from addition, or from deletion. That is, whether you could do a breakdown of different neighbor types.
Yeah, that's an interesting question. We haven't broken
We haven't
down.
done
that. So we will, we'll look at that. Which of these operations actually results in what is the neighborhood size depending on what type of operation? That's a good idea. We
will have to look in future. Yeah.